Good afternoon, class.
Good afternoon, Mrs. Boy.
Thank you. You can sit down. All right, then what we will do today is look at the last question, I think, on the previous exercise, which was question 8. And then we'll go on to the next part, which is based on tangents and tangent properties of a circle. All right, question 8. Okay, question 8. Calculate the height of the segment marked Y. Anyone with an answer for question 8, please? Patrick? Give us your answer to question 8, please.
Y equals 1.53
Y equals 1.5 what?
centimeters.
Centimeters, okay? Correct. Okay, that completes all the questions on the chord of a circle, the properties of a chord of a circle. Okay, we'll go on to the next thing, which is based on tangent properties of a circle. What I will do is I'm going to write the properties of a circle on the board. And as I do, I'll explain it and then see if you can get them down in your exercise books. Okay, the first one. Okay, tangent. Okay, tangent properties of a circle. The first one is this. If a tangent is drawn from a point outside the circle, I'll call this point P to the circumference of a circle. Okay, first of all, note a tangent is a line that just touches the circle at one point. Okay, not more than 1 point. It's a line that touches the circle at 1 point. So if a tangent is drawn from a point outside to the circumference of a circle, it will be perpendicular to the radius. Okay, so if this is the center of the circle, which is always denoted with the letter O, from the center to the circumference is the radius. A tangent drawn is always perpendicular to the radius of the circle. So from a point outside a circle, okay, a tangent, sorry, let me rewrite it again. Okay, a tangent okay, I'll just use this to mean perpendicular to. Okay, tangent drawn to a circle from a point outside a circle is perpendicular to the radius. Okay, that's the first tangent property of a circle. Okay, the second one is similar to that. Two tangents drawn from a point outside the circle are equal. Okay, so if the point is T, and this is A, and this is B. Okay, these two tangents, if they are drawn from one point, then these two tangents will be equal. When that happens, okay, what is this this shape? It is a kite, okay, because these two are equal, then these two are actually the radius of the circle. They are also equal, that means the shape that is formed is actually a kite. So two tangents drawn from a point outside the circle okay, those two tangents are equal. Okay, number 3. All right, make sure while you are writing, you are listening as well. Okay, if this is the tangent, this is property number 3. And this is the angle formed between the tangent and a chord that is drawn from the point of tangency. Okay, the point where the tangent touches the circle is called the point of tangency. So if this is a chord and this is a tangent, this is the angle formed between, or this is the angle at the point of tangency. Okay, I'll call it angle B, and this is the chord. Okay, this angle is actually half, this angle will be half of the angle at the center of the circle. Okay, this is, sorry, my circle is not really good. Okay, if I just move the center to the middle. Okay, this angle here is actually half of this angle. I'll call it angle A. So angle B is equal to half of angle A. Note again, this tangent, okay, this is the tangent, maybe I'll call it PT. It's drawn to the circle, and this is the chord that touches the tangent here at the point of tangency. The angle formed between that chord and the tangent, which is angle B, is half of angle A, which is the angle at the center of the circle. Clear? Okay, so I'll just write that down. Okay, the angle between the tangent and a chord okay, drawn from the point of tangency equals half of the angle at the center. Okay, note something important. That angle must be subtended by this arc. It must be formed by this arc, sorry, the chord and the two radii. Okay, That's important. All right, that's number 3. Number 4. Okay, you will note this book contains only 3. If you use this book, it contains only 3 properties. Okay, we are going to look at, I think, 5 or maybe 6. Okay, number 4. Tangent. Angle. Okay, the 4th one, the angle between a tangent and a chord drawn from the point of tangency equals the angle at the circumference subtended by the chord. Okay, note the difference between property number 3 and property number 4. I'll just explain by using a diagram. Okay, maybe X, Y, and T. Okay, YT is the tangent of the tangent to the circle. The point of tangency is this point here. Okay, this is the chord. There are 2 segments. Okay, if this is the chord, there are 2 segments that of the circle that is divided by the chord. There's one on this side. Okay, here, all of this one is the major segment, and this little bit is the minor one. Okay, note where the angle is. The angle is on this side, which is the other segment. Okay, it's the segment on this side. This angle here, which is the angle created by this chord, and the tangent at the point of tangency, it's exactly the same as the angle here, which is at the circumference on this segment. Clear? They are equal. And this angle here is subtended by this chord. That's the chord that we are looking at. Okay, the angle here at the point of tangency is equal to the angle at the circumference. Is it clear? Okay, that's property number 4. Can I remove this? Okay, we go on to property number 5. Okay, if two circles touch internally or externally, then the line which passes through their centers also passes through the point of tangency. Okay, so if these two circles touch, this one they're touching outside, the line that passes through their centers also will pass through the point of tangency, which is the point where the circles touch. Okay, that's if they meet outside, if they touch externally. Okay, if they touch internally, the diagram slightly different. Make sure you draw good circles, not like mine. If this is the center of the bigger circle, and this is the center of the small one, this time they are touching inside. The line that passes through their centers will also pass through the point of tangency. Clear? Okay. The last one. See if I can write it here. Drawn. Then centers. Okay, if from a point outside a circle, two lines are drawn. Okay, this is wrong. One secant and the other a tangent. And the square of the tangent is equal to the rectangle. Stop here first. Okay, then if from a point outside a circle, two lines are drawn, one secant. Okay, a secant is different from a tangent. A tangent is a line that just touches the circle at one point. A secant is a line that touches the circle at different points. Okay, and I'd like you to remember this for grade 12 as well. If, let's say we have a curve like this, a tangent is a line that just touches the curve at one point. A secant is a line that will touch the curve at 2 points, like that. So in other words, a chord can actually be called a secant as well. So I'll just draw the diagram to explain further. Okay, TC is the tangent. CT is the tangent because this line touches the circle only at one point. Okay, AB is actually the secant. Okay, it says if from a point outside a circle, two lines are drawn, one a secant and the other a tangent to the circle, then the square of the tangent is equal to the rectangle contained by the whole secant. Okay, which means the square of the tangent, the length of the tangent CT squared will be equal to AC times AB. Okay, so AC multiplied by AB. Sorry, not AB. Wrong. BC. Again, CT squared, you square the length of the tangent, that will be equal to AC multiplied by BC. Okay, so it's this length multiplied by this. Okay, and that's property number, what, 6. Okay, those are all the tangent properties of a circle. What we are going to do is look at the exercise and maybe do question 1. Okay, that's the exercise on tangent properties and maybe another question. Okay, when you've finished copying, we can do one question. Can I remove this side of the... Okay, see if you can try number 1. I'll give you 5 minutes and then we'll do it together on the board. Okay, let's see if we can do this together on the board. Just note, I forgot something on property number 4. Just write where you drew the diagram. Angle A is equal to angle B. You should have written it down, but so I said it, but then I didn't write it down. Okay, the two circles on the diagram. All right, those of you who have the textbooks, I do not want you to write on the textbook, please, because some of the pages have already been damaged by students writing over and over on those diagrams. If you want to write on them, get a photocopy, and then you have your own paper to write on. Because you are going to destroy. Some of the pages are already torn because of that. Okay, this is a big circle and a small one. And that small one is drawn in such a way that it touches the big circle on the outside. You are told to find x, and x is a length that is given like that. Okay, the diameter of the small circle is 15. Okay, like that. And the diameter of the big one is 50. Okay, if I can just explain on the diagram on the monitor. To find x, what you need to do, because you are told in property number 5, the lines that are drawn from the center of the circles touch the point of tangency. They go through the point of tangency. So what you do is this. You draw a line from the center that will pass through the point of tangency. It will also go through the center of the small circle to there, to this point. Okay. What you will do is from that point, which is the center, to somewhere here, you will draw a triangle from here to there. Can you follow? All right. From here to here is half of 15, which is 7.5. Okay, you will draw a circle from, a triangle from here. It will go like this, up to that point and down. This one will be 7.5. The triangle will have a hypotenuse of 7.5 plus 25, which is half of 50. You with me? Okay. And then from here to here is 25. That's half of 50 as well. So you are going to add 25 and then plus the length that you will find from here to here, which you have to use Pythagoras theorem. From here to here, you will work it out, because from this point to here, it will be the same as from here to here, which is 7.5. Are you with me? And then you will just take away 7.5 from 25, and you will get the length there. And that's the length you will use, plus the hypotenuse to give you this. And then you will just add that to 7.5 and to 25 to give you the length of x. Did you follow? Okay, if I can do it on this. See, this one is not a really good one. I'm not a good, I don't draw very well. If I can just move this down a bit. Okay, like that. Now, from the center to here is, sorry, you can't find that out, because from here to here is 7.5. But from here it's 7.5. because it's half of, it from here to here is 7.5. That's half of 15. So this is already 7.5, we know. From here to here, if you look at the diagram correctly, it's 25. It's half of 50. You agree? Okay, so this is 25. So 25, we know that from here to here is 7.5. So all you have to do is find the distance from here to here. And to do that, you draw a triangle from here to here and here, and that goes through the point of tangency to the center, right, following property number 5. This is 7.5 and 25. So 7.5 plus 25 will give us what? 32.5. So the hypotenuse of the triangle is already 32.5. What is this distance here? 17.5. 17.5, this is 7.5. It's the same as this one here. So 17.5 from 25 is 7.5. So this is 17.5. So using Pythagoras theorem, if I can call this A squared is equal to 32.5 squared, which is this distance, that's 7.5 plus 25, minus 17.5 squared. And A will be the square root of that. Please. Is that in centimeters? It doesn't say. Okay, 27.4 to 1 decimal place, 27.39 to 2 decimal places. Okay, try number 2. Now you have to find H. Okay, for number 2, H includes this height from here to here. Am I right? Oh, no. Okay. From here to here. H is from the top of the circle here all the way to here. Am I right? Okay, so this is H. Now H includes this bit, right, which is this. It includes from here to here, and then from here up to here. All right, let me just remove this. Again, make sure you look at the diagram in your textbook. Okay, this is easy, it's 10. And if the diameter of the small circle is 10, then from here to here is 5. So from here to here will be 5. So there's 5. All you have to do is find this distance. Okay, the hypotenuse of the circle is going to be 10 plus 5, which is 15. And from here to here is 10 plus 5. Sorry, not 10, it's 12. 10 plus, where does 2 come from? Okay, there's 27. Okay, if this is 27, and it's going to be 10, this one is 5, and the leftover will be 2. So 10 plus 2 will be 12. This bit is 2, this one is 10, because you are told that from here to here is 27. From here to here is 27, so 10 plus 2 will be 12, so this is 12. So 15 squared take away 12 squared will give 81, and the square root of 81 is 9. So this is going to be 9. So H is equal to 10 plus 5 plus 9, which is very easy, 24 units. It doesn't say whether it's in centimeters or not. Is it clear? Okay, I would like you to do this exercise in your groups. And you will answer them in your groups. Everyone is to do them. I'm going to give you which one each group is to do the next lesson, and you'll have to explain. Okay, so you do the rest of the exercise for homework. Question 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, the keyword to the pilot teacher is properties. Good afternoon, class. Thank you.